are talking about this problem. This line is AB and we are taking the projections of this line AB over here. We have got some sort of angle. This angle would be with the horizontal plane. We are having some sort of angle. When any line is inclined to HP, angle with HP would be a must to have the projections of any line. Always first front view would be traced like this. Front view we have traced. Now if you see, the front view would be exactly the true length of this vertical plane. Now if we talk about the top view, how this top view would be presented. These are the front view component will always denoted by A dash and B dash. It is having some sort of angle like this. Now if we talk about the top view, as you can see over here, we are looking from the top. Now I'm very glad that you might be knowing that the top view projections will be traced on the horizontal plane itself. Now so if we are seeing from the top, it would be landing on the horizontal plane like this. So if you see, these two lines are tracing a line on the horizontal plane, but as you can see, if you are tracing any sort of inclined line into a straight line, then its length would be reduced. That we will discuss on the later part. This is our top view. This would be the top view, always denoted with the small letters A or B. Like this, we have taken the projections, light projection till the XY line, and we have taken it to the small AB. Its orthographical representation, as you can see over here, its orthographical representation is very much clear. This red is our line. Original line is our red line. If we trace the projections of this red line from the front view like this, we are retaining the exact angle as well as the length. We are retaining both these things. But if we are talking about the top view, if we are seeing it from the top view, as you can see over here in the orthographical projection, the top view length would be shortened. If this front view length is 100 mm and angle is 30 degree, and if we trace the projection of the top view, then it might be 90 mm reduced by 10 mm. The reason behind this is we have just straightened this line from the any angle. You understanding that? If we are inclining any line and if we are straightening it up, then this line length would be reduced. This line length may be reduced. So what would be our true length? A dash B dash would be our true length. A dash B dash would be our true length, but this would be our projected length. In some of the problem, you might be asked that take the distance of this top view line. If you are drawing it completely okay, if you have drawn the angle properly, if you have drawn the true length properly, then only you can find the right answer for this kind of problem. Now the fourth problem. a line is inclined to VP but parallel to HP. How we can see the pictorial presentation? We are having horizontal and vertical plane. As you can see in this portion, the line is starting from the vertical plane. A line is having some sort of angle with vertical plane. As you can see over here, a line is having some sort of angle with the vertical plane and parallel to HP. It is not on the horizontal plane, it is parallel to the HP. Then how we can have the projections of it? Very simple, totally opposite to this problem. In this problem, we have got the true length in the front view. In this problem, we will get the true length in the top view because it is inclined to vertical plane. Very simple and easy logic. If any line is inclined to any plane, then that plane will not contain its true length. The true length would be always in the another plane. If any line is inclined to horizontal plane, then true length in the vertical plane. If any line inclined to vertical plane, then true length would be on the horizontal plane. Very simple and very easy logic. Now we will take the projections of it. We are having some sort of angle with the VP. We are seeing it from the top view first. As you can see over here, we have taken the projection A and B. We are seeing it from the top. Then nomenclature would be small a, small b. Now, if we are talking about this front view, how this front view can be adjusted? A front view can be directly traced in between the AB line, but it would be always into the smaller side. If we are straightening any inclined line, then it would be shorter length. Same rule applies over here like this. Inclined line is there, inclination with the horizontal plane, true length achieved in the vertical plane. But if we see in the orthographic representation, if we straight the true length, then the length would be reduced. Same would be applying over here. The line is inclined to vertical plane and true length in the horizontal plane, but if we straighten it up, then it would be shortened in the vertical plane. It would be denominated by A dash B dash. It is front view. Here is the orthographic projections of this problem. As you can see over here, the front view is having the shorter side. The front view is having a shorter side. It is A dash B dash. As you can see over here, the angle with the vertical plane is called as phi. Angle with the vertical plane is called as phi. This angle is something given. Let's say this angle is given as 60 degrees. This length would be a true length, because if we take the projections of it from the top view, then we can have exactly parallel projection to it, and we can get the true length of this plane. So these are the basic concept of any projections of line. Last problem is remaining. A line is inclined to HP, a line is inclined to VP. Very simple. We'll see the next problem. A line is inclined to both HP and VP. Now, this is some sort of tricky thing. a line is inclined to both HP and VP. The third and fourth problem was one line was inclined with HP and one line was inclined with VP, but another would be parallel to any plane. But in this, a line is inclined to both HP and VP, then it would be very much interesting to see how this kind of pictorial presentation can be done and how this line look like. We are having as usual horizontal plane and vertical plane. This is our XY line. This line is not parallel to horizontal plane, or this line is not parallel to the vertical plane as well. It is inclined at some angle with both the plane. If we are tracing from the front view, first of all, then its projections will look like this. Tracing on the vertical plane, as you can see, if the line is parallel to the vertical plane, then it must come as exactly to this. But this line is not parallel to the vertical plane. The inclination have been changed. We are now having top view. We have got some sort of angle over here, that is alpha, because the angle projection would be parallel to the XY line. The first point would be always parallel to the XY line. So from that we can have the angle. Now we will see the top view. Very easy. Like this. Angle with the horizontal plane is phi. Angle with the horizontal plane is phi. Totally opposite with each other, called as AB. Like this. Now if we see the consideration of these two planes, then it would be totally opposite like this. If we straighten it up, then we cannot get the true length. For this we need to have some sort of arc to take the true length. As you can see over here, in the front view, the A dash and B dash have been clearly shown and the angle is alpha. Whereas the front view is shown up as AB, as you can see in the top view, and the angle would be denominated by the phi, and this would be our true length. On removal of the object, any line AB, the front view is image as VP and top view as an image on the horizontal plane, like this. The orthographic representation can be seen over here like this, that these two lines have been having some sort of inclination with each other. The alpha and the phi clearly shows the difference. In this portion we cannot get the true length very easily. We need to take some sort of arc and we need to have the distance of this front view length or the distance of this top view length. From that only we can have the true length actual. Both front view and top view are inclined to XY. Not any single view is parallel to XY. Both front view and top view are reduced length. It do not show any true length, as I have already told you. Now, if you see this HP and VP component, we are having both this line not having any sort of true length. Orthographic projection means that front view and top view of the line are indication with the parallelism. We have taken these two projectors. As you can see over here, we have taken the projectors parallel to the xy line. From this is our xy line. From the point A dash, we have drawn a parallel to xy line, a parallel to a line. From the B dash, we have drawn a parallel line to the xy line. Same way, from the point A, we have drawn a parallel line to the xy line. We are seeing it from this side. Here is the top view, which is not parallel to xy. Hence, it is not showing the true length and the true inclination with the HP. It is not parallel, because of that it is not showing the true length. How we can have the actual true length? We are having front view and top view, but how we can find the true length? The views are rotated to determine the true length and the inclination with the horizontal plane and vertical plane. We will incline some sort of angle to find out the true length as well as inclination with the horizontal plane and the vertical plane. As you can see over here, the same thing have been mentioned. This is our top view, this is our front view. We have drawn a line like this. Now, what we have done, I have taken this arc as AB, the radius as AB and center as point A, and marked down an arc till the line which is parallel to xy but generating from the point number A, like this. Now what I am going to do, I will just extend this line, I will just extend this line to the B dash parallel line. I will just extend this line to the B dash parallel line. And when I